I'm now handing over to Elijah. Elijah, over to you. Thank you.
Thank you, Zoe, for the poll questions and also the introduction. Okay, I'll take this chance first to thank our attendees for finding time to join us in this webinar. So this is just one of our, we are currently doing them on a quarterly basis, but now we are looking at increasing the frequency to monthly. So looking at the various tools and improvement within the Autodesk design solutions for infrastructure. So today we are just going to focus on the new improvements within the 2020 release, specifically in the Civil 3D and the Infraworks. So we're not going to spend much time, but possibly maybe 30 minutes maximum, plus maybe 10 minutes Q&A at the end. So just feel free, as Zoe has mentioned, if you have any question, you can just post them at the Q&A tab. Then I'll have a look at some of them towards the end of the presentation as well. So we'll just briefly look at what this enhancement that we are focusing on today really integrates to. So the main focus in our infrastructure webinar presentation are basically looking at the roads and highways, airports, rail, and bridges. So with respect to the various Autodesk tools that we are focusing on today, we are basically looking at the improvement with the BIM and GIS integration, also the introduction of the Dynamo for Civil 3D, which basically allows a design automation within Civil 3D, road rehabilitation, civil structures, collaboration, and what have you amongst the different improvement and integration within the Civil 3D and the Infraworks platforms. So also this one is also something which is still new, but maybe a number of you who are using 2019 and 2020 might have already started working with this BIM and GIS integration, where mid last year, Autodesk and A3 partnered, and now you can now directly access ArcGIS Online and also ArcGIS Enterprise and start getting your GIS information directly into your design model through Infraworks. So previously, people used to get or work on their GIS information on either Map 3D or AutoCAD, or just the normal workflows that you're used to. But it's now changing and being made easier, where you can have your BIM model together with the GIS information integrated into one design model. So those are some of the enhancements which has happened in the past 1 year, but still more are still happening, and we hope that a number of development will also still be happening within the 2020 release, as we are also now expecting the 2020.1, or in the next 1 or 2 months, we'll be having a 2020.1 with a number of enhancements. But today we are just going to focus on what's already present. We won't talk about something which is still for the future. So to start, we'll just go directly into Infraworks. So Infraworks 2020 had a number of improvements, starting with the update in the ArcGIS connector, where previously you could only access GIS information from ArcGIS connector, but now you can save back your GIS information, the one that you have maybe updated or worked on within Infraworks. You can update it back into your ArcGIS Online, or if you're having access to ArcGIS Enterprise. The same also applies to the extension of the schema transfer, which is more or less similar with the saving back into the ArcGIS connector. But also more important is the spreadsheet-based edits of structures, where this makes it possible for the bridge engineers, those who model bridges, tunnels, and what have you within Infraworks interface, can now export the bridge structure in terms of the model component, that is the sizes, to go and customize it further within Excel spreadsheet, after which you can go and update it back within Infraworks interface. So also there is the update on the component road cut and fill material, where basically you can now change specific color for your cut and fill, just be able to differentiate between the areas along the maybe that particular road corridor that you are cutting and the areas that you are filling. And also, more importantly, is the conversion of a traffic simulation to desktop. So for those who have tried this out, or those who have used the traffic simulation within Infraworks, you realize that the previous releases, you could only perform traffic simulation in the cloud. So where you first had to maybe define your traffic study area, define your traffic demand, then it will go into the cloud, perform the simulation, then you can download it and start maybe playing it within Infraworks model. So that functionality is now being made to the desktop, where you don't have to worry about things like maybe the cloud credits, which some many people are having a lot of questions on that, maybe where they have exhausted their cloud credits, how to maybe buy more, or how to get them. In this case, you can now perform your traffic simulation even when you are also offline. So you don't even require internet connection to perform your traffic simulation. And also moving on into the future, you will no longer be able to perform a traffic simulation if you're using 2019 and the earlier versions, meaning they are going to discontinue the cloud traffic simulation, and therefore you'll only have to move into 2020 to be able to perform your traffic simulation into the desktop versions, that is 2020 plus the coming versions. So just going to have a brief preview of each of these features that has been updated within Infraworks, starting with the first one, saving back into the ArcGIS. So as I mentioned, basically it means that once you have accessed your ArcGIS information on the ArcGIS online, where you basically choose the various features, but you now have to specify that you should enable editing when you are going to work with them. So you have to first specify the settings within your ArcGIS online, that when you access those features, like maybe the existing sewer lines and other corresponding utilities, like maybe the manholes and what have you, you just have to specify that enable editing, meaning that when you go back into, when you now access them within Infraworks, you can now start maybe editing things like the cover, the slopes, the depth, or just the overall position and orientation for those corresponding GIS information that you are now working on within Infraworks. So then once you're complete or you're done with your editing, you can now save it back into the ArcGIS platform from where you would got them. So basically this now gives you now a more control or rule over what you're working with, or the information that you're getting from within ArcGIS. And this works both for ArcGIS Online and ArcGIS Enterprise through the Autodesk ArcGIS connector that is found within Infraworks, as you've just seen on that preview. So the next also is the extended schema. So again, this, as I said, work closely also with the GIS information, but you're now transferring the schema between different features. So it basically allows users to add additional types of features to their models, as well as additional properties onto existing features. So this will allow the users to benefit mostly from the ability to manipulate and manage the metadata in their project design information or design model. And also, as previous, I'll just also give you a brief preview of the same, how it works. So still within Infraworks. So if it is the building or maybe the roads, you just go into their properties and start changing the parameters in terms of the schema or the metadata that that particular model component that you are interested in has. So like maybe the name, the display, the type of how it's going to extend that information that you're talking about within the Infraworks. So you can have the building which are customized, or the same building that you had got from Infraworks within Infraworks interface itself, or it can also work with even the GIS information that you have got from ArcGIS platform. So whether they're roads, whether the parcels or land uses, or just buildings as you have seen. So you can now start changing this information in terms of what the respective information that that particular model component has, so that you can save it back into the ArcGIS platform as well. So then moving forward again, the next, which I said this is particularly interesting for those who find maybe trying to customize the specific bridge component in Infraworks difficult. So for example, if you want to have a custom abutment shape and size, pier shape and size, or girder, or even the bridge deck. So just maybe from that existing bridge, it's very, very simple. So you just have to select that particular bridge and say send to the spreadsheet. And if it's the first time you're doing that, it'll ask you to create a new, and it opens it onto the Excel. So you'll be able to see the different sheets, bridge, overall bridge, the deck, the pier, foundation, abutment, deck, and water view, so that you can now start specifying the exact sizes in terms of dimension that you want to have. So immediately you're done with that, you just save that Excel sheet. So the only thing you need to ensure that you don't change the position of the location of that Excel sheet within your computer. Then you just go back into Infraworks and click update. And as you have seen, it automatically updates the bridge sizes in terms of the dimensions that you have defined on that particular Excel sheet. So that's, I'm very sure, since most of the engineers usually are used to working with the Excel, that's something which I'm very sure you'd be keen on trying out to enable you customizing your bridge components. So this works also even with the various custom shapes, maybe the one that you might have modeled from, for example, Inventor, and you now want to customize them further. So instead of going back into Inventor and trying to change those sizes one by one again, you can just automatically export that into Excel sheet and update them accordingly. So again, this more of just to control the visualization and the display of your elements within Infraworks. So where you can choose a different colored display for a cut and fill. So for example, if I'm having that existing road, I may choose the color for my cut to be red, and that's what most people uses. Or then I go and choose the next color for fill, which is red in many cases. So in that case, it just basically enhances the display of your road corridor, road model that you are working on within Infraworks. So it doesn't add anything to do with your design features, but just in terms of display. You want to be able to easily know the areas that you are cutting and the areas that you are filling within Autodesk Infraworks. So those are some of the key enhancements. So unfortunately, I won't have a preview on the traffic simulation, but as I mentioned, just basically allows you to perform traffic simulation within the desktop without having to rely on the power of cloud computing. So you don't have to be sending your model to the cloud and re-downloading the traffic simulation model onto the Infraworks to start playing it. So in this case, it just works instantly. So those are some of the key features which have been improved within Infraworks. So then moving forward just to the Civil 3D, where we are having a very good and interesting feature in terms of Dynamo for Civil 3D. So for those who have used Revit before, or those who have heard of the Dynamo itself before, you realize that it's quite an important automation software within the Autodesk product portfolio. So for Civil 3D, it basically allows engineers in this case to perform visual programming and add the power of Dynamo and Dynamo scripting into the 3D model. So like if you want to now maybe automate corridor modeling, you want to automate addition of different objects within the road corridor, like maybe if I want to automatically do street lights along my road corridor, in this case, we can now create a Dynamo script, which will automatically allow us to perform that placement of the object within the corridor, or things like maybe the retaining walls, or overall Civil 3D objects, either from 3D polylines, 2D polylines, or other blocks from AutoCAD. You can now automatically start creating scripts within Civil 3D and use Dynamo to help you automate your design process. So I'm very sure engineers and overall designers will find this very, very important to them, because it will help you eliminate some repetitive tasks, which usually consumes a lot of your time when you do them manually within Civil 3D interface. So also maybe the question which I'm very sure I'm likely to receive is maybe how to get you started. So maybe you can share with you some link which basically gives you some start some points where you can start in terms of the maybe existing script that you can edit, or just some tutorials which can allow you to start learning Dynamo for Civil 3D. Also, another announcement which also appeared within the 2020 release was on the storm and sanitary analysis, which I was quite impressed with this, since it has been a very long time before Autodesk took time to maybe upgrade or add some features within storm and sanitary analysis. So this upgrade within the storm and sanitary analysis has been updated in terms of maybe performing your tailwater conditions, also being able to generate your peak rate factors for dimensionless hydrographs based on the sub-basin that you're working on, and also being able to update and add new storage chambers within your drainage or stormwater model. So this also still applies to drainage engineers or overall civil engineers who are interested in maybe performing hydrologic and hydraulic analysis within their infrastructure model. So also another improvement is in terms of the analysis of gravity network. So this is also something which had been missing, where people had been using, maybe going to other third-party products like Ethernet to perform this. So you realize that with the 2020 release, you'll be able to perform analysis for the gravity network, so where you'll be able to maybe know the expected flow without having maybe to export your model into storm and sanitary analysis to be able to generate the results. So then also there are those other improvements in terms of maybe also being able to generate Civil 3D rail alignment that can also be interpretable with Infraworks. So I'll just take again some short videos to illustrate the first four, so that it just gives us an overview of how that happens. So with me here is just a short presentation on how we can use Dynamo within Civil 3D platform to automatically position and place for us street lights within a Civil 3D corridor. So let's just take this, so you'll be able to see. So we are having an existing corridor. So what you need to have is, first you must have the street light in blocks. So you can maybe these are existing AutoCAD blocks that you now want to work with within the Civil 3D, and that's your assembly, the corridor assembly that you want to place it. So you basically need to know the point within the placement point within the assembly. That's the code itself, where the feature that you want to add will be attached within the corridor that has been modeled. So it's only important that you need to know the exact name for the assembly on which the traffic light is going to be, not the traffic light, sorry. You need to know the exact name, the exact point code, and then you now start creating the script. So in this case, you want your script to work manually. So it basically that you basically need to be updating it manually. So in this case, we are going to work with an existing Civil 3D model or CAD model. Then you define Civil 3D. Then you select the specific corridor by name. So we have a corridor which has been modeled. So just a matter of, so maybe for those who have not worked with the Dynamo before, so these are the kind of the scripts. So just using more like a linear programming interface, where you define how one step leads to the other. So like if I want to place these street lights onto the corridor, at what positions, how frequent should they be placed within that particular corridor that I want them to be placed on what surface am I going to place them? So each step will be leading to the next. So now that you have identified the corridor on which you place them, we choose the corridor baseline. So baseline is now going to the one which is associated with the point code that you have selected. Then you specify where is the first point going to be and where is the last point going to be within the corridor feature line that you have selected. So basically that's how Dynamo works. So it's just a matter of selecting and defining what leads to the next in terms of the features that you want to have within the corridor that you want to model that particular component. It could be any other structure. It doesn't have to be only street lights. So then you're now specifying the code. So I said that you must have that existing block of the light pole or the street light. So then you now link it to the code and associating it to the specific feature line along the corridor that you want it to be placed. So remember that you have specified it's going to be at a particular point code within the assembly. There's the assembly which was used to create that particular corridor on which you want to place it. So then you now define the start and the end. So then between the start and the end, how frequent are we going to do it? So you can either use a slider where you will say that you'll be able to change the frequency of the street light along that particular corridor at any given time, or you can choose a specific value. So let's say maybe you want to have them at maybe 500 meters, 200 meters along the corridor. But in this case, it is preferred if you can leave it by just saying that I want to be sliding it. If maybe I see that 200 is more frequent or they are closely spaced, I'll be sliding to lower the number or sliding to increase the number. So like in this case, you can say that by starting with a default value of 200, you should be able to maybe see how frequent does 200 appear on that particular corridor model you are looking at. So you can go further again, still after having defined the frequency now. You now need to again associate the start and the end with a specific position now. So along that particular, now that you have defined that I want to have them at maybe 200 meters along the corridor spacing, at what specific station in terms of elevation and X, Y along that particular corridor am I going to have them? So in this case, you can maybe choose a specific origin along the Z or Y, or a combination of X and Y plane, and choose the corresponding elevation. So that is in terms of Z, because also it's going to be a 3D model within the corridor that you are placing. So in this case, that's why you now need to choose the coordinate, and the coordinate must also correspond to the specific orientation based on the model that you are having. So remember that we all know that Civil 3D models are all georeferenced, and therefore you need to know that you must have selected the correct coordinate for the use within the Civil 3D models. In this case, just allow it again to automatically read the coordinate for the Z, the coordinate for the Y, and the coordinate for the X that has been used for georeferencing of the Civil 3D model. So this script that you are creating is something again which you can reuse later. Okay. So again, in terms of coordination, just saying it's going to be a vector for Z, vector for Y, vector for X, basically allowing you to be in a position where you can again change, like how high or how tall should my street lights be. So that's in terms of Z. But in terms of the X and Y, will basically be controlling like the gap or the diameter or the corresponding size of the street light that you are doing. So that's basically how Dynamo works. So we'll be able to see that once you are done with your complete script, you just click to run. Okay, so just click to run. And when you run it, automatically be able to see a number of street lights being placed within our corridor at the specified spacings. So remember I mentioned that you can use a slider to allow you to automatically adjust the spacing, which basically controls the number. Okay, or you can use a specific value. So like I can see sometimes you may be experiencing like maybe an error where it basically wants you of some specific values, which you may just go to the specific node within your script and identify that particular error that is coming out. But if you click run, you can now see within our model, we now have the street lights have been automatically placed based on the number of spacings that you have identified or we have used within our script. So if you see that they are too frequent or some of them are not within the correct position that you want them to be, you just go back into the script and now use the slider. So slider adjusts the position by increasing or lowering the value. So it makes this kind of design very, very easy. So just imagine where you are to place these 3D blocks one by one, or by trying to project them on the section view. it's likely to take you maybe more than 1 or 2 hours. But just like once you have the script, you find that it's something you can easily do, and you can reuse that script at any given time. If you need to change the position, you need to change the orientation, like maybe the rotation angle and what have you, you realize that it will become very, very easy and interesting in terms of eliminating such tasks which sometimes become repetitive in terms of how many times you want to do it. So like, for example, if you have maybe a road of even 2 kilometers, doing that will take you quite a long time. But if you have the right script for Dynamo within Stable 3D, just a matter of some minutes and you're done with creating such related 3D model component within your Stable 3D interface. Okay, so let's move to the next improvement again, which is still within Stable 3D, but with respect to storm and sanitary analysis. So as I said, so basically this is focusing on the tailwater, peak rate, and storage chambers. So basically you now be able to now define within your analysis options, you can define whether the outfall boundary is going to be fixed condition or varying, normal or free. Then you now define the elevation for the water at your tail end. Then you now define the subbasin for the specific storm that you want to design for. Then after that, you can now look at the specific peak flow factors within the drainage network that you have defined. And don't forget that the best way to create all those parameters in terms of the pipes and the pipe network is start them up from Stable 3D, so that when you go into the Stable 3D, basically define your specific sub-basins and the basins within the model. So in this case, this was a tool which was missing, where you could not easily define your peak factor values, and also you're not able to specify the tailwater conditions within the model that you're working on. So then after that, you can now start seeing your curve storage with respect to the depth and volume. And basically, that's something which I'm very sure you'll be able to try out and see how it impacts your design in terms of generating your peak volumes for the specific flow rates within the pipe networks within the storm and sanitary interface. So again, the next improvement also, as I mentioned, is on the gravity network, where I said this now allows you to perform analysis for your pipe network within Stable 3D. So we know mostly within Stable 3D, we are just able to lay out our pipe networks. So laying out in terms of the slopes, the cover, and also maybe defining just the overall pipe network orientation within the surface that you have. But now, with this new improvement, you can do some level of analysis for that particular pipe network. So you can perform analysis for the gravity and be able to apply the results to the pipe. So results in terms of the discharge, the results in terms of maybe the volume of flow, in terms of velocity of flow, things like the Manning's coefficient, you can now specify for the specific pipe, whether it is concrete. Though that used to be there, but the only part which was missing is that you could not be able to generate the results in terms of your flow, whether it's flowing at maybe 0.5 diameter or 0.75 diameter. So with this improvement, you can now perform such analysis and be able to replace it with the model-less dialog box, and it can now enable you to interact within the Stable 3D interface without having to look for third-party products like EPANET or sending your model into storm and sanitary analysis to be able to generate such results. So again, just a quick view to show us basically how that happens. So you have your storm water networks, that's the pipe and the corresponding structures. So you can choose and select the specific structure there and then start defining your flow. So you can start from a known flow, or you can start from a known area. So remember that with the known area, we can apply different formulas like CIA to give us the corresponding flow within that particular area. And of course, that's after having performed our catchment area analysis Then after that, you can now start looking at the specific pipe network structures, both in plan and profile, and start specifying the various parameters in terms of flow. So then after that, you can now see you have your minimum cover pipe slope, and then from the flow that you have defined, we can perform analysis to see that from the intake area going down the stream, which pipes do we have that are going to maybe flow above the minimum required value. Then you can export that in an Excel spreadsheet, where you basically be able to see your results. So like you can be able to see this result here, basically giving us the specific pipe from where it starts to where it ends, the exact length. Then if you go towards the end of that Excel sheet, we're able to see the specific pipe diameter, the full flow. So if the pipe is of diameter 2.7, what is the expected maximum flow? That is from the overall discharge that you are defined when you are performing your analysis. And of course, as you can see that the pipe which starts upstream basically contains the more water, and also be able to see that you are now able to even generate the results in terms of the flow velocity. So these are what you're now supposed to check against the minimum design requirement, because we know that different pipe for different materials basically requires maximum flow velocity to guard against maybe erosion within that particular pipe. And you can also be able to see the specific invert levels, both at the start and end of the pipe, and also the slope and the cover. So these are some of the kind of results or reports that were missing in the previous release. But with the new release, you can be able to understand this better. Things like the hydraulic gradient line, the overall energy within that particular pipe. So that's the V squared over 2G. So I won't go into details on that, but these are some of the things, again, which I'm very sure you can or are likely to be interested in seeing. So instead of maybe still looking for some other third-party products to integrate within Civil 3D, you are now able to perform analysis of a gravity pipe, so that you'll be able to generate this kind of results. Okay, so moving on to the last one, I think. So the last one, sorry, I'm getting some latency from my side because of the connection. Okay, sorry for that. I've just run into an error with my presentation. I'll just have to close and restart it. My apologies for that. Just bear with me, please. Just get it on very, very fast. But I think we are just to the last part. We are on the last one, which I'm very sure should be this one. Okay, so then I will share the screen. Okay, just sorry for that. So from current slide, so I think it was in the last, that's the way we are. So Zoe, can you see my screen?
Yes, I can, Elijah.
Okay.
You'll just need to put it in presentation mode.
In there?
You will just need to put it in presentation mode.
Okay.
Yeah.
In the presentation mode. It's not in the presentation mode yet?
No, not yet, no.
Now?
Yes, now it is.
Okay, sorry for that. Okay, so I think that's the where I was. So basically I was showing the analysis for gravity networks. So we are going to see where you can perform the analysis and customize the specific pipe networks within the model. So that's in both profile and plan, and also be able to see your specific pipe discharges or flow, and also things like the HGL, that's the hydraulic grid lines. So that means that's something which I'm very sure will also enhance your workflow. So then the last part, okay, seems I don't know what's happening on my side. My slide, just my PowerPoint keeps on running into an error. Well, I'm on the last bit. So I'll just do it one more time. My apologies for that again. But I think it's just the last PowerPoint which could be having such problem. So the last one should be basically an overview of some other additional the additional enhancements. So let me just try it once more. Sure. Sure. Current. Okay, so the last part is basically looking at the other enhancements. So I'll just mention this one. I won't show any short videos on the same. So the most important among these other enhancements is the ability now to be able to export or the interoperability between Infraworks and Civil 3D in terms of railway alignment. So this was missing in the previous versions. So like with the 2019 release, you were able to do rail alignment, and there was a specific tab introduced for railway alignment, railway design. But you are not able to see or export that railway alignment into Infraworks and vice versa. So this was also improved in the 2020, where you can now export it in an MX file and be able to even have that visually impressive view of that railway alignment within Infraworks, plus its corresponding corridor. So there's also other improvement in terms of the survey database formats and the migration of utility. There's also the railway platform edge, so to the Chinese standards, because I'm very sure there's some, with the invasion of the Chinese contractors in Africa, they're basically contracting most of these projects, some of them the railways, their specific design standards. So this also can still apply to Africa, also not only to China. So that has also been made possible, where you can now do the railway platform edge to the Chinese design standards. Also the ability to export Civil 3D drawing to rework, and also being able to now reference your templates. So that particular add-on within Civil 3D again now, which allows you to perform the referencing of the various templates within the Civil 3D template libraries. So those are some of the few improvements that I was able to capture. But if there is need, we can go in details, maybe by scheduling a specific customer presentation to you, where we now not use the slides and the videos, but we go to the specific software, be it Civil 3D or be it Infraworks, and look at each of those functionalities that we have just looked at briefly on this webinar in details to see how they can help you improve within your workflow. So I think basically that's it from me, Zui. So unless there are questions, we can have a look at them, or if there's some specific questions that are directed to me, we can now answer them. Okay, so I've just seen one question where someone is asking, why are you still using Bing images? This is not as dated as Google Earth. Okay, so Bing just comes as a free imagery within Infraworks in form of that image. So it basically it's meant to help you start the project. So you're not supposed to use it where you know that the project will go to the detailed design level. So as a start, you can just start the project using those Bing images within Infraworks. But if it's something which you now need to go to the detail further, it's advisable to recommend that you have to go and collect the data in form of imagery. You're either using the drone or any other source of imagery for that particular project area, and use it to update whatever you already had within Infraworks. So you just can't use it. It's what's already present, freely available within Infraworks. You can't use it for detailed design. It's just meant to jumpstart you into your infrastructure design. And that's currently also available, and we are aware it's up to date. It's not up to date, and in some areas it is as old as 3 years ago. So you can't really use it to do your final design or detailed design. So just basically meant to jumpstart you into your project. And once the project maybe is approved or you got some funds, you can now do surveying, either using drone to collect the data for photogrammetry, or you can use ArcGIS now to update that particular infrastructure model that you have created within Infraworks to ensure that you are using up-to-date imagery for that particular Infraworks model that you're having. So it's not recommended to use the Bing map within Infraworks as the detailed at the detailed design level. Any other questions for us, or you can only see one question on the Q&A tab?
If you have any questions, please use the Q&A. Thank you. Okay, it doesn't seem like we have any more questions from our attendees. I'd like to thank Elijah for the presentation today. We will be sending out a recording to all our attendees, as well as a short survey to complete during the course of the week, before the end of the week. If you could please have a look at that. Thank you all for attending today.